Hi, my name is Valentina Piantatossi and I am a PhD student at University of Molise. This study has been accepted at ICSI 2021 like J1 Talk, and this paper has been accepted in the journal Empirical Software Engineering. Code reading is a very important property of the source code. In the literature, Bennett et al. And Raiche et al. Say that the code reading is the very first step during incremental change because it is used to do concept allocation, impact analysis, and change implementation. This theory is reinforced by the study of Ehrlich, in which is interested to note that developers are very busy in the maintenance of the code. In addition, this code is brightened by other developers. Indeed, we conducted a survey with 122 developers to understand to what extent code readability is important to them, and about 84% of developers consider the readability during the writing code. In the literature, there are some guidelines on how to maintain a readable code, but there is an open question. How does the readability of a source code evolve over time? For this reason, we define a model able to describe the readability evolution of a given file in a software project. This model is based on a Markov chain, and it is as four states of a source code file. Specifically, it is has two main states. File can be readable and can be unreadable. And this is the core of the model because readability values have a change between these two states. A file can be readable and can become unreadable or vice versa, as a file can remain readable or unreadable. Also, there are other two initial states, so non-existing and other name. Specifically, the file is non-existing when it is not created yet, and the file is other name when it exists with a different name. To answer our open question, we created two studies. The first study is used for the validation of readability prediction in software analysis, and the second study is focused on the readability evolution. The context of our study is based on 25 Java open source projects with at least 100 commits. Specifically, we focused our analysis on about 83,000 commits. For each project, we extract the history of each file that appeared in its revision history. To achieve this goal, we analyzed the commit logs extracted from Git repository of the project. To do this, we only focus on Java source file. We choose the tool by Scalabrino et al. Because it implements a comprehensive model for automatic code readability assessment. For the first study, the principal question is the following. Are readability prediction models suited for predicting readability evolution? And this study is guided from the following research question. The first research question is, which readability value lead to classification errors? To answer the first research question, we used the dataset provided by Panduchin et al. This dataset contains about 1,300 commits in which developers explicitly mentioned that they improve code readability. The dataset includes the readability value measured before the commit and after the commit, besides other metrics. At first, we associated to each commit the corresponding transition based on the R before and R after, using the same procedure we use to build our dataset. After we extract from dataset all transitions where R before is greater than or equal to 0.5 and R after is lower than 0.5. From our manual evaluation, the tool by Scalabrino et al. Is unreliable in the range between 0.4 and 0.6. On the basis of this range, we remove 112,000 transitions from our dataset. Also, our first study is guided by another research question. So, is the readability prediction model suited to assess the readability transitions? For the second research question, we extract 271 transitions for a significant stratified sample. This sample is divided on 8 transition types that are the intersection of states of R before and states of R after. 3 of authors perform a manual evaluation with a 5-point Likert scale, where -2 means that the evaluator is totally disagree with the tool, and +2 means that the evaluator is totally agree with the tool. From our manual evaluation, results show that the readability model for transition is less accurate compared to the readability model for single version. For the second study, the principal question is the following. How does readability evolve? The first research question for the second study is, how often does readability change? For this research question, we extract 10,000 subsamples with repetition from our dataset. We use the M out of N bootstrap, where M is the original sample size and M is lower than N. In this way, we computed the probabilities of transition in code readability evolution model. From our result, we can see that the code readability of an individual file rarely changes during the evolution of a project. Indeed, the probability that a file becomes unreadable is lower than the probability that a file becomes readable. The second research question of the second study is, how and why does code readability change? For the fourth and last research question, we extract 57 files with a big variation of the readability. 2 of the authors manually analyzed the history of this file, annotating if the change is adaptive, perfective, or corrective, and what is the reason of the readability change between structural, visual, and textual aspects. We found that the 82% of the cases were caused by adaptive change. The 50% of them were caused by perfect change, and the 3% of them happened because of corrective change. Also, perfect and corrective change improve the code readability. Instead, adaptive change don't improve the code readability. For other 3 aspects, we can see that there is a deterioration of the readability for the visual aspect. There is an improvement in the case of textual aspect, and at the end, we can see an equality for the structural aspects. From this result, we conclude that the big code change in which new code is added are most prone to reduce code readability, and that the variation of readability are unintentional. From our result, we extract some guidelines to help developers keeping the quantity of unreadable code low. From the third research question, we can observe that readability hardly changes during software evolution. Thus, developers don't write code that should improve in the future. Always in the third research question, we observe that unreadable code is produced with the creation of new file. Thus, developers should review new file a big change. From a result of the fourth research question, we can say that developers should prefer small incremental change, and they should refactor when possible. For the future, we could define of a readability transition prediction model. We could improve the readability transition model, and we could experiment the use of the readability tool in continuous integration. Thanks for the attention.
Okay, so we're live now for the Q&A. My name is Francisco Servant. I'm going to be your session chair today for the questions for your paper. We have Valentina Piantadosi, who's the first author of the paper, and Alexander Serbernik, who is also an author of this paper. So we're ready for your questions. I'm going to leave a few moments for people to write questions in the chat. First thing is you got praise for your nice presentation. That's always good to hear. Okay, so then the first question is, it's nice work again, and the question is, did you investigate what specific changes developers make to the source code to improve readability? So for example, say using a better name for an identifier, reducing the lines of code in a method. Can you talk a bit about that?
In our study, we investigate the structural aspect, the textual aspect that are the changing on name of for identifier, for an increase or decrease of the lines of code, or good or bad indentation. And we investigate this type of changes.
Okay, thank you. So while people are thinking of their questions, I would like to ask you one also to continue the conversation. So I was curious if you could talk a bit about your observations in terms of, did you see like when readability increases importantly or decreases importantly, did you see any relationship with bugs being introduced?
Yes, in our result we can observe that the bug fixing improve the readability, and generally the file are readable instead of readable.
Okay, that's an interesting observation. Bug fixing, improving readability, that people are like,
Yes.
they
Other, for example, refactoring improve readability.
right. Okay, great. Let's see, do we have more questions from the audience? Okay, so in the meantime, I'll ask you another thing that I was really curious about.
Okay.
So I wonder if you saw any kind of relationships also between these kinds of changes, readability improving or decreasing, and the experience of developers, right? So basically, do the more experienced people write more readable code, or we cannot really say that?
In our study we perform a motivating study that are asking a survey at developers if developers improve the readability, and developers the developers consider the readability in writing and in reviewing of the code to increase the readability.
Okay. Thank you. So it's interesting. The next question was actually the same question that I asked. Do you have any insights of the experience of the developers that improve or reduce the readability? So next is, congratulations for your work again. And did you consider other readability metrics like views, postnet, and if you didn't, why?
For the first answer, the experience of the developers are PhD industrial developers and students, and no, I consider only the metric of Scalabrino et al. And I don't I don't consider these other metrics but,
Maybe I can comment on this. So the model we have considered by Calabrino, it included features from the previous model. So in some sense, we did not consider previous metrics in isolation, but ultimately they've been included in the model which we have used.
Thank you. Okay, so next question is, if I understand correctly, the data set was labeled by developers. But for example, maybe they believe the code was more readable because they're more used to reading it, or they know something about it. So do you see an agnostic way of measuring code readability?
Yes, the code readability there is can be measured before with the readability transition model that in the literature there is not present. Now we are metrics that measure the readability on the simple version and not on the transition.
Okay, thank you. So we still have a few more minutes to get questions from the audience. Okay, next question is, did you perform your study on unit test code and production code? And if yes, did you notice any patterns?
Our study is performed on the production code on GitHub repository, and we notice that in the project there are readable files, respected to unreadable files, and the longer the history of the project is the higher the risk of introducing the readable file.
Thank you. Okay, so we have still 1 minute, maybe enough for one more question if there is one. If not, I'll still remind the audience that a discussion room will open after this Q&A finishes. So if you think of a question later, you can just join the discussion room and you can find the paper by its title in Clowder also and leave your questions there anytime. The room is persistent, so the questions can be answered later as well. So because we only have a few seconds left, I'm gonna finish thanking you for your presentation and your work and your great answers to questions. Thank you very much.
Thanks. Bye.
Bye.